Okay, let's continue in this page wherein we could see a list of student outcomes expectation. So we have defined the basic concepts of highway and railroad engineering and apply in civil engineering practice. Number 2, recognize the concepts associated with geometric and structural design of highway and railroad engineering systems. So take note, geometric meaning we will apply surveying, and the structural we will apply structural design or the specialty structural analysis. So number 3, explain the basic service requirements of highway and detail the procedure to conduct level of service. Okay. Service requirement, because roads enable the government to provide services to the public, okay, by means of providing the opportunity to travel in comfortable condition. Okay, so without highway, without roads, how do you think we would travel from point to point? We may be walking for long distances. Maybe we would be taking a bicycle on rough roads. Okay, maybe we would be riding a horseback riding on very rough terrain. Okay, so these highways and railroads are what we call infrastructure. Okay, so they are usually the responsibility of the government to provide to its citizen. Okay, and develop number 4, basic traffic stream parameters, model and apply queuing theory. So queuing theory is a very high level type of management applied theory. Okay, it is a scientific way of specifying desired characteristic. For example, speed of what processing all the data. For example, as simple as how many cashiers would I design to provide client services for what? For example, McDonald's. How many cashiers is required? And you will see the queue in McDonald's. What do we mean by queue? We mean the lining up of person, no? The persons are falling in line for each and every what? For each and every cashier in order to buy something. So they will fall in line, one after the other, okay? So queuing theory solves and specify how long a particular client, meaning for each and every hour, different hours during the day of different queuing requirement. Okay, so there is a rush hours of sort when we are talking of what? Fast foods. Okay, so within what 11 o'clock to 3 o'clock, those are the rush hour of sort. Okay, and about 6 p.m. To 8 p.m. So those are the rush hour for fast foods. And the specialists in this field are actually, do you know who are the specialists who solves this problem? They are, this is actually a professional course of industrial engineers, queuing theory. They will what? They will solve problem on how long is the queue for each and every cashier, for each and every branch of the McDo, for example. Okay? And why they are 4 cashiers instead of 3 or instead of 5. So they know it. Okay? So it could be solved. Could be solved. In a similar manner, we need queuing theory for traffic. So there are intersections where vehicles will wait for their turn to proceed. Okay, so how long must they wait for each and every particular traffic traffic light, no? Okay, or intersection. Okay, for each and every intersection, how long? So those must be computed, those must be calculated. Then they are now applying this concept. Before, there is no application of this concept. Okay, but nowadays they are applying this concept, and particularly there is a another professional course in industrial engineering, what we call the operation research. Okay, there is a transportation model there that they are studying, transportation model. But here our problem is the real transportation. In industrial engineering, the transportation problem is about what? In industrial companies, industrial manufacturing companies, the travel of goods, the delivery of services, the delivery of parts, for example, from one production line to the other production line. Okay. In a way, it is really similar to the transportation problem of civil engineers. But it is only one topic or 2 topics, while in industrial engineering, that is really a major subject, 1 or 2 subjects. Actually, operation research, 2 major subjects, 6 hours, okay? So really, these are the area for professional practice of industrial engineers. I don't know if they are being employed in Department of Transportation and Communication of our country, of our government, but definitely they could help because of those skill and expertise on these things. So, for example, in operation research, we also have what? We also have the scheduling the problem in our project management. That is also an area of the specialty of industrial engineering. Okay. However, we can do it as a civil engineer if you study hard enough. Your knowledge and capability, skill would be no less lower than an industrial engineer. So it depends on the person really. So we are preparing you to have some sort of an idea about this, but definitely we cannot lecture completely about queuing theory, about project management on highways and railroad projects, okay, and operation research or transportation models, okay. So we cannot do it that. We will just give you an idea, explain them, and make you aware. We will make you aware that these things exist. Okay. So, by the way, I am also an industrial engineer, being a graduate of BS Industrial Engineering. So, our course outline for the whole semester, according to CMO 92, 2017, number 1, we have to discuss importance of transportation and its characteristics. Okay. Number 2, highway development and planning, the process, procedure, how they are being applied in practice. Number 3, design criteria for highway and railway system. And number 4, geometric design for highway and railways. Number 5, structural design of railways and pavements. Number 6, failures, maintenance, and rehabilitation. Number 7, traffic engineering and traffic flow analysis, including queuing. Number 8, pavement materials and design, specification, and test on pavement materials and design as per IRC. This is what I'm talking about. IRC is a code that specifies standards for roads and highways. Okay, and IRC means Indian roads. Okay, Indian road. So it is an Indian standard. Okay? I don't know why we are copying it from India. Usually we are copying all the codes from United States, not knowing that there are other countries who might have better codes, like what? Japan, Europe, but we are usually copying from United States. Okay, and as you can see, we have an ample list of topics that cannot be discussed within the time limitation of this course, 3 units. And this is a constructive example why you have to enroll in a review center, because only 2 out of these topics, about two subtopics are the what? Are the subject of board exam in this transportation and engineering. 2 subtopics out of this, what? How many? 8. Okay. So this is a practical, constructive example. What I'm saying is that review center or reviewers will not discuss everything. All of these 8 are actually and equally important, but in the board exam, only 2 of these. Okay, what about the other? No. So your knowledge, if you are just depending on the board exam, will not be actually useful in practice. Because if you only know 2 out of 8, it is not useful in transportation engineering. Okay, so at least you have to get more than 4, because there are 8, more than 4 of these, or 5, 6, 7, 8. Okay, before you have a good grasp of the specialty of the specialization. Okay, so this is one practical example of what I am saying. So and maybe because of that, maybe I would focus on something else rather than those areas that are being taken by the review center. Okay, so that we will cover more or many things. Okay, so if ever I could be able to discuss 6 And then the two will be discussed by review center. After you graduate, you have to enroll on their curriculum, and then therefore you will be complete. You have a complete knowledge of this thing. But in my view, another important thing here is what pavement materials. Okay, materials, it is being used practically, actually being used by the contractor, pavement material and designing. And we will use what? Number 5, structural design. So transportation engineering needs structural analysis and design. Okay, because a road is just like a flooring, and we are designing floors. Okay, and the support mechanism of the floors. Why we don't design it similarly as in transportation? Okay. Another question. Where do you think bridge is included? Do you think bridge is included as structural or transportation? So structural specialization or transportation? The bridge. Okay. As you can see, bridge is not included here. There is no mention of bridge. The bridge is actually in the structural, but as you will discover, there is no mention of bridge on the courses common to all of the civil engineering. The bridge will pop up on the specialty subject, okay, under the structural. Bear in mind that whatever the learnings that they will gain on structural design, it will also be useful here because we have structural design, but limited structural design, but not only limited, another perspective of structural design, because we are usually located over and above the soil, and the soil must be studied properly because in every location there is a difference between the characteristic of the soil. Another thing is the load that will utilize our structural elements, okay, are heavy loads and actually moving, sometimes very fast, okay, because they are big vehicles, okay, okay, so heavy. And when we are talking of buildings, they are designing buildings, structural design of building. The loads are just what? Human beings, people with what? How many kilos? 75 kilos, 70 kilos per person. Okay? Maximum. Okay? So, very little. How about the smallest vehicle, smallest car? Smallest car is about 1 ton, 900, 800 kilos. So, there's a clear big difference between the loads. So, the structural design of roads must be better than the structural requirements of floors of any building. Okay. Okay. Sometimes in the highway, there are trailers, 10-wheelers, okay, heavy trucks, heavy vehicles. Okay? That would have it. Okay. So, delivery trucks, which are heavy equipment. Okay. So, meaning to say, the requirement must be severe load requirement. Okay. And we have the following references, codes, and manuals. As you can see, we have highway engineering textbook on your left side. At the center, we have another author, highway engineering and traffic analysis. So traffic analysis is included. So I think traffic analysis is written on the, well, number 7, traffic engineering. So traffic engineering and traffic flow. So it includes not only queuing, but what? The basic form of traffic signs, symbols, road signs, okay? They have standards, okay? That's why we have DPWH standard for it. So at your right side, we have DPWH standard specification for public works structures. Okay. So in this document, it is a book. It is very thick book. Okay. Too much for us to handle. That's why we will do it in some innovative way like this. We will do it in this way. Okay. We will what? In all of our videos, we will give you 1, 2, 3, or even 5 questions. Okay, so like this, and you have to answer. Okay, you have to answer, research for it. Okay, and answer in the comment section of the video. Okay, together with your other comments. Okay. Okay, so for this particular course, highway and transport and railroad engineering, because the topic so much to handle. Okay, so we cannot do it all, so that's why we will insert many things on our lecture video. So, question number 001. Okay, what are the laboratory tests for steel bars? This question is out of this, what? It is out of this, from this reference, DPWH, okay? Which is what? Cited by the CHED CMO 92 series 2017. It's called Standard Specs for Public Works Structure, and popularly known as Blue Book. Okay, and also, by the way, I am also interested with this because you can take an exam, and if you pass, you will awarded the title Materials Engineer. So that's why it is important here. Number 8, pavement materials and design. It involves testing. As you can see, specification and test. Okay, so it's very important. Actually, they are being followed. And do you know what? Materials engineer salary is too much. For a single, for example, for a single contract, they could earn 50 to 200,000. Sometimes, very few of them could really earn 1 million per contract, more than 1 million per contract as a material engineer. Okay, so material engineer is not just knowing how the traffic works, knowing how the infrastructure have to be analyzed, designed structurally, designed management level for the purpose of queuing and traffic control, and implementing standards on symbols, road signs, and so on. Okay, so road signs and symbols are having standards because because the driver, if you're going to other countries, you should be able to be familiar with the road sign symbol. Even if in other countries, for example, in Japan, the writing system is not English alphabet, so but the symbol should be somewhat similar. Okay, so that is the reason why there is a standard. Okay, so anyway, this is how this course, this video will work. So we'll give you sort of quiz, but questions. Okay, question. Okay, questions. Okay, sort of quiz or sort of activity, and will be monitored. It will be monitored, and also from this area of concern, I will also from time to time give you quiz about 5 to 10 items, short quiz, very short quiz. No? So what are the laboratory tests? So we are actually asking for the name of the test or what type of test it is for steel bars. What type of test are we going to do with steel bars? Okay. We are going to do a comprehensive test. Letter B, a bending test. Letter C, compressive test. Letter D, both B and C. So there is a date, March 2018, meaning this question really was asked during the materials engineer exam. So it is like a board exam, but not everybody can take this exam. Only licensed civil engineer can take this exam. Okay, so as a civil engineer, we can take this exam. You will have to show your license that is valid. So even if you are a civil engineer, if your license is not valid or expired, you cannot take this exam. Okay. So let's continue with our introduction of the course. Another set of references, standards, specification, and codes for construction of concrete roads. So as you can see, Indian Roads Congress, IRC. This is a code that we are following as suggested by CMO 92 2017. This is the document at your left side. Okay. And because we are also doing structural design, NSCP. Okay. And of course, one of the document from, again, the PWH, Highway Safety Design Standards, we have what? Road signs and pavement markings. Okay, the use of paints, the use of symbol. Okay. This is part 2. There is another book, part 1. Okay. So there are plenty of books requirement for this course. Actually, there are about 6 to 8 as suggested by the CMO. Okay. So next is about our grading system. So there is an additional effort that we will do in order for us to learn about the pavement materials and testing, evaluation, maintenance, and so on. Okay, by asking you questions every now and then, we will insert those questions throughout our HRE videos, okay, lecture videos. So therefore, we will add some criteria here because of that. So I will design it. I will give percentages. So that is my responsibility. But I will inform you about this. Okay. So definitely we'll do that because that is in fact included in the topics to be covered according to the policies and standard for civil engineering. So definition of the course from the title. Okay. So again, this is not PRPCD but HRE. HRE meaning highways and railroad engineering. So what do you mean by engineering? Again, what do you mean by engineering? So what do you mean by highway? So highway is a road. Okay? We are talking of road. If we say highway, we are talking of road. And actually, we are specifically talking of public roads. Okay, when we say highway. And highways is a little bit general because one meaning of highway is a road, a public road that connects municipalities, cities. Okay, so what about railroad? What about railroad? Railroad is a means for transporting human beings, people, goods, products, transporting something from one point to another via vehicle that utilize rails, okay? Vehicles with rails. So we are talking about trains and the like, okay? So, and on your picture in the background, that is the picture of probably would become the first subway system in the Philippines. This subway system is under construction right now. So this is the one of the picture. Okay? So I used it as a background for this slide. Okay? So it is a Japanese technology. That's why I'm very interested. So Japan as is the number one in subway technology. Okay, so they drill a whole mountain. Okay, so to make the transport more comfortable, and this is drilled about, I think, about 7 to 10 meters below the ground. Okay, so it is it is lower than the foundation of most buildings. So even, I think, even lower than 10 meters. Okay, this subway is even lower than that because the foundation easily could become 10 meters. Foundation of a high-rise building easily 10 meters. Okay, for example, 15 floors, 15 floor building, 20 floors building. So foundation is about 10 meters easily. Okay. So this is lower than the 10 meters foundation of those buildings. So they drill. So the only risk here is flooding. No. What about if there's a flood? Actually, Japan has a transportation system underwater. Okay, they drill under the mountain and connecting island to island, they pass through underwater. Okay. Okay. So some of the islands, neighboring islands, are connected by those type of tubes, okay? And they must be deep enough so that ships and boats, speedboats, uh, could be able to travel along the top of the surface of the water, okay? So imagine that. So, okay, and the buildings in, for example, Metro Manila, wherein this subway will be, is actually or is currently being constructed. There are so many high-rise buildings, so meaning this subway is really what uh, deep below the ground. So that is what we mean by highway, railroad, and engineering. Uh, I would like to ask you one by one what is the meaning of engineering. That's why I am avoiding to define it myself. So I would like to test your